The project is an investigation into how a layering of different programs of an aquaponic farm, public parkland, data center, and a working port can all be integrated as an ecological and socially sustainable system to become an urban catalyst for the master plan of Bays West. The presentation is structured with 4 key topics of focus. Firstly, I will be talking through the overall master plan and urban strategies, then talking in scale of the building, its layout and components. Thirdly, I will be presenting the heat and cooling strategies, and lastly, ending with an investigation into the construction of the building and its materials. From the beginning, there was an ambition in the master plan to provide an elevated platform and parklands, which the data center would sit underneath. This diagram contextualizes the evolution of the shape and form that took place during the design development from Assessment 1 on the left through to its current iteration as shown in the right. The current master plan is built upon 3 big principles. First, there is to be a reconnection back into country by remediating the natural flora and fauna. Secondly, there is to be a celebration of a diversity of precincts, such as energy, food, data and water, which all as a whole is able to become an innovative precinct for the future. And lastly, there is to be an emphasis on the connections of public and active transportations, reducing the use of privatized vehicles. The master plan is proposed as a combination of new introduced landscapes, such as the mangrove forest, number 3, sandy coast, 5, headland wetlands, 6, and a playground and recreational park, 4. Not only does this provide a sustainable outcome, but acts as attractors to bring people into the site and encourage them to explore further. The master plan also respects the existing context of the site by retaining the working port, the grain silos, and the White Bay Power Station. The data center has 3 simple principles. Firstly, there is to be a layering of 2 horizontal planes. The access to services of the data center is to be on the ground through the working port, while overhead sits a public plane. Secondly, the data center is to act as a main connector for the pathways from Pyrmont and Town Green to the remediated Headland Park through the large boulevard. Thirdly, the data center is to be constructed as a repeated modular system, allowing for more localized layouts and also future-proofing if need be. As shown in this aerial sketch, the data center sits above the existing working port, as shown by the number 7, and acts as an extension of these landscapes via an elevated platform. It also brings together public from the Pyrmont through the reinstated Glebe Island Bridge, as shown by number 9. As mentioned before, the building is made of a modular system. Here you can see how a single modular system can be multiplied across to cover a large expanse. A finished module is made up of 4 key building components, as shown through the exploded isometric. The 4 are 1. Portal frame as the main structure, 2. Express cores, 3. Layered programs, including the data center, and 4. Deep soil planters. The portal frame is made up of 6-meter grids, where on its sides it is cross-braced for lateral strength. The large portal frames allows for the public domain to be columnless. The building systems and its risers are situated on the edge of the portal, utilizing the structural zone. This allows the buildings to have no penetrations on the main floor itself. Similarly, for circulation, the same cores are used to house the lift and fire stairs. This allows the ground floor to remain open for services to remain undisturbed. Through this sectional perspective, we are able to see the build-up of all the different floors and layers starting from ground, services, Level 1 data hall, Level 2 public domain, and Level 3 the aquaponic farm. To begin, the ground floor houses the services of data centers that are heavy-duty and obtrusive. These include the plant rooms, generators, and electrical rooms. The ground floor works with the port through the introduction of a rail system, and by enlarging the circulation zones, a modularized generator compartment is easily able to be pushed in and out where necessary. This allows for easy maintenance and easy replacement in the future. This perspective is taken from the working port looking at the building. You can see the express cores on the edge and the expansive ground floor and its open corridors. You can also see on the left a modularized compartment waiting to be pulled into place in the building. On the floors above sits the main data halls. In plan, it is enclosed by deep soil planters that sit above the circulation corridors. The secondary spaces, such as communication rooms, staff rooms, are situated in the front of these data halls, allowing the data halls to be thermally isolated from the exterior. There are 2 communication rooms as specified and are placed in each ends to ensure that if one fails, the others can be used as a backup. This visualization is from the inside of a data hall, imagining what it could be like when inside the cave-like space. On levels 2 and 3 sits the public parkland and the aquaponic farm above. On level 2, the parkland can be divided into zones. First is the main boulevard that connects the wetland headlands. Secondly, the function pods that are spread throughout the landscape to provide potential retail or marketplace space. And on the southern side, a more private pathway that could be used as a share laneway. Lastly, sitting above the deep soil planters are long strips of large canopy planting, as shown by the trees in the plan. Directly above sits the aquaponic farm that almost floats above the parklands through utilizing the structural zone of the portal frame. The floor plate area on this level is minimum to increase the scale of the space below. Here you also have the cooling tower situated away from the public face, sighted towards the south, as shown in number 3. Through this perspective, looking at the public domain, you can start to imagine the layers of vegetation, landscape and greenhouses above and how it starts to break through the structure. Now that we have gone through the building layout and program, we can go through the heat and cooling strategies of the building. Generally, the building not only provides a way to reuse the heat, but acts in reducing the overall heat of the data center to a constant temperature with 6 principles. Principle 1, cooling with a natural canopy. The proposal utilizes an overall soft surface and large canopy to filter sunlight and as a result lower the overall temperature of the building through reducing the urban heat island effect. Principle 2, constant temperature with thermal mass. The data halls are surrounded with well-ventilated deep soil planters that help the temperatures inside remain constant throughout the day, night, and yearly. Principle 3, water collection and reuse. By utilizing the large expanse of a public domain, the building acts as a retention basin that collects stormwater runoff in a water tank to be reused for further cooling if required. Principle 4, single-phase immersion cooling. The data center configuration uses a single-phase immersion cooling. This uses a non-evaporative coolant, which is able to efficiently lower the energy required to cool servers and provide a way to efficiently distribute heat to be reused through the building. Principle 5, using the ancillary program of an aquaponic farm. The waste heat is used to control the temperature of the water used in an aquaponic farm. Moving down the individual planters and tanks, the aquaponic farm is able to combine both hydroponic and aquaculture to provide a sustainable means of food, but also reuse the heat from the data center. The 6th principle is circular ecosystem. The proposal utilizes the water, food, energy and heat to create a circular ecosystem that are all thoroughly integrated. The chosen materials for the project are site and program specific. Firstly, the northern facade is layered with a wired system which allows for climbing vegetations to grow. This allows the building facade to act as an extension of the landscape and also provide natural shading. The cladding to the vertical core is a polycarbonate to allow for a dispersed light to enter into the building. It also allows the building to feel light and inspiring for those outside and inside. The large concrete waste, as a result of carving the existing concrete master plan, is to be recycled as aggregates for gabion walls, forming retaining walls in the landscape. Steel was chosen as the main structural material due to its strength and weight ratio. Green steel, made from hydrogen, was chosen as an alternative to reduce the carbon footprint in traditional steel manufacturing. Similar to the gabion wall, the recycling of the concrete aggregate is also to be used for the concrete in the deep soil planters. The concrete is to be pigmented in earthy colors to act as an extension of the landscape and connect back to country. Finally, I would like to end by coming back to the macro scale of the data center in the master plan and its connection to the wider Sydney Harbour. By utilizing the benefits of large canopies and thermal mass, it is able to cool down the data center, which in turn is able to provide heat for the farm, which is then able to provide back to the community and the public. Hence, the proposed data center and its ancillary programs are just only cogs in the wheel of a larger urban and environmental cycle.